Now we talk about the periodic properties and trends of the periodic table. So when we talk about the properties and trend, we're gonna talk about the atomic size, the nuclear, the shielding effect, the electronegativity, ionic size, and so on. So let's take a look about the atomic radii. Atomic radii is defined as a distance between neighboring nuclei in a molecule crystal. So the atomic radius will be affected by the number of energy level and proton pulling power or effective nuclear charge. So uh, when we see the periodic table, so across the period it will decrease the atomic size because of what? The same level of energy, but the increasing the effective nuclear charge will shrink the atom. Down in the group, it will increase the size of atomic because the increasing the energy level, and the effective nuclear charge decrease due to the repulsion in the inner shell and the outer shell. Okay, next is a shielding effect. Shielding effect we talk when the reduction of effective nuclear charge in electron and caused by the repulsive force to other electron between it and the nuclei. So across the period, the repulsive charge, let's say this one will become bigger, the repulsive force to the other electron in the nucleus will increase. In the atomic with one electron, that electron experience the full charge of the positive nucleus. However, in atom with many electrons, the outer electron are simultaneously attracted to the positive nucleus and repel by the atom. So you can see the increasing the shielding effect downing the group from the group at the top level corner. Going down the group, it will increasing the radius based on the energy level and the shielding effect that I stated before this. Okay, so cesium has more energy level, so it's become bigger. So the atomic size trend you can see here, joining the group, it will increase the number energy level, thus increasing the atomic radii. Across the period will decrease the atomic radius. In terms of ionic size, metallic will lose the electron. Metallic is from the group 1 and 2, and non-metal is from the group 17 up to group 17. So you can see here when they're losing the electron, let's say sodium, when losing the electron, it will decrease the size, but when gaining electron, it will increase the size. The concept as simple as that. When it losing electron, it will decrease. When it gaining electron, it will increase the size of atom. In terms of ionization energy, what is ionization energy? Ionization energy is the energy that required to remove one electron at the valence electron. So let's take a look at the periodic table. When across the period, the ability to lose electron will harder. Let's say this one is sodium. Sodium will easily lose the electron, so less energy required to remove one electron compared to the group 17. Group 17 will make it harder to remove the electron due to the due to the increasing number of inner electrovalence electron. However, donning the group, it will increase it will increase the it will decrease the ionization energy, because the ability to remove electron will become easy for the last corner of the periodic table. Because of the increasing the number of energy level, it will easily remove the electron at the outer valence electron, and because of the increasing the shielding effect, it will cost less energy to remove one electron, so that the ionization will decrease. So in term of ionization energy, you are looking to the periodic table here. Some of the element have their certain out of the averaging to lose electron, like boron, like nitrogen. You can see the different, a large jump here. They have a reason for that matter, and you can check it at the notes given to you. So in summary of ionization energy train, successive ionization energy increase as the atom more positive. When the atom is more positive, the ionization energy will have a high tendency to remove electron. There is a large jump in ionization energy when the electron to be removed come from a new shell. Let's say they are from the shell of S, P is here. So if the electron to remove one electron in the P orbital maybe become more easier rather than the electron from the S orbital, since this is a new shell closer to the nucleus. For example, between second and third ionization energy for magnesium. Magnesium, you know, is magnesium 2 positive. When they are going to the next level atau new shell, it will harder to remove one electron from the S orbital. So next, the total energy to remove more than 1 mole of electron is equal to the sum of each mole added together as above. Okay, next term is electronegativity. Electronegativity is the ability of an atom in a bond to pull on the electron. So this one is a ability, the strength to make it attract the electron going to the negative parts. So as the electron are attract closer to iodine, it becomes slightly negative, and the hydrogen atom becomes slightly positive. The more negative the electron is, the atom is, the more they have ability in terms of electronegativity. But when the when the atom are the same electronegativity, they are give the same pull of the electron equally. So, the more negative of the ion will increase the electronegativity. So donning the group, it will increase the electronegativity and across the period. Okay, electron affinity is a uh, is a counteract with the electronegativity. For electronegativity is energy that's required to remove one electron, but in electron affinity, energy released on adding up one mole of electron. So in order to counteract the repulsive force, energy has to be provided to the system. Therefore, the value of the second electron affinity is always positive. So you can see in electron affinity, you can see in the notes, electron affinity, across the period also same the ionization energy. The more ion energy required to ionize, to remove one electron, also the electron affinity, the more they give the electron affinity for this at the top right corner here.